If you paid attention to the talk before, you know that not everyone interacts with the app in the same way, because we cannot rely only on visual information. People actually can use like external devices like keyboard or assistive technologies. In the Android world, the most common assistive technologies are the TalkBack, which is the screen reader that provide spoken feedback for visually impaired users. And also we have the voice access, which is an hands-free control. You can use your phone by voice commands. So how this assistive technology can actually understand what's on the screen. Today we're going to talk about a topic which is becoming quite popular nowadays, but it's still something that is not addressed by the beginning. And that's it, accessibility in mobile apps. It is also quite funny that my talk is just straight after someone that says how to exploit your app with accessibility services, but you know. So before we begin, just a quick introduction about myself. So hi everyone, I'm Luca. I'm an Android expert digital engineer and mobile front-end and e-commerce, which is a division of customer experience identity data. If you want to find out more about us, you can come to our desk at the exhibition room, or for those who are online, they can scan the QR code. This is the last talk before the lunch break, and I'm actually starving right now, so I guess I'm not the only one, so I'll try to do my best to stay in 30 minutes-ish, so we can get first to get food. This is our agenda of the day, and we start with why accessibility matters and how to achieve it. So to begin, I want to start with the definition of accessibility. So what is accessibility? Accessibility is just making text bigger and adding alt text for a small group of people. So actually nobody really cares about it. And that's false. So I can see some of you may be confused in the audience. So those actually are common misconceptions about accessibility. So we try to move on and see why accessibility really matters. Accessibility means inclusion and equal access, because over 1 billion people globally live with some form of disability, like visual impairment or auditory impairment. So, I mean, it's like 1/6 of the global population of the world. So, you know. Also, it means a better user experience, because with accessibility features, all the users can have benefits. So, like for example, if we are in the bright sunshine, low vision features can make our apps usable. Then, making an app accessible expand our potential user base, so we can actually reach our broader audience. You are not excluding any group of users, so you can get higher retention and engagement by your app. And then, last but not least, the guy before me just talked about it, but I want to just deep dive a little bit more. Accessibility is also legal compliance, because many countries have laws such as the European Accessibility Act in Europe, or for the US market, they have the Americans with Disability Act, which requires that our platform must be accessible. And speaking of European Accessibility Act, I just want to deep dive a little bit. The deadline for private sector is by June 2025, and no compliance with the European Accessibility Act actually can lead to legal repercussion, fines, and also lawsuits. But not all the companies are actually affected. So the European Accessibility Act does not apply to organizations with fewer than 10 employees and with a turnover of less than 2 million euros annually. So a friend of mine told me that this meme is quite boomer, because I'm quite boomer, but if you don't want to be hit by a train when your company hires the 11th employee, just make sure to start now and build accessible apps, okay? So now we have seen why accessibility matters, but actually, what is the standard of compliance with the European Accessibility Act? The European Accessibility Act focuses on meeting the practical needs of people with disabilities, but does not itself actually provide any specific technical standard for accessibility or guidelines. To do so, there's the WCAG, which stands for Web Content Accessibility Guidelines. And with the WCAG, we actually have 3 levels of compliance. There's the first level, which is a basic one. Then we have the second level, that is the level that we have to address to actually be compliant with the European Accessibility Act. And by addressing this level, actually, our app can actually be used by pretty much anyone. And then we have a third level, which is level AAA, which is the highest level possible. It is quite challenging to achieve it in mobile apps, but I mean, it's not a requirement, but if you want to do so, go ahead for it. It's nice from you. And maybe I can see some of the audience that is confused, because we actually said what is the standard for compliance with accessibility, with the European Accessibility Act, but we are not actually going into what does it mean in mobile development. And to be compliant with the European Accessibility Act, we must ensure that these 6 categories are managed actually correctly. So starting from the top left, we have the text size. So any user should be able to increase the font size of the phone and be able to use our app. So we don't have to have any kind of breaking layout. And the scale must be perfectly usable from 100 to 200%. That we must guarantee a 48 by 48 dpi size for all the interactable area. So this is the touch target size. Actually, if you are using composable from the material and standard libraries, they actually have inside already a constraint where the size must be at least 48 by 48 dpi. Then we must provide content descriptions to all the images that have actually semantics, a semantic meaning to the user. And we must guarantee a good color contrast between the text and the background. Also, our app must be usable and adapt to orientation changes. So you can use it both in portrait, landscape, size, or foldable devices. And then we must guarantee a keyboard navigation, a full keyboard navigation. So the user actually can use the keyboard to navigate our app. So, who needs accessible app? Accessible apps are needed by people with disabilities, like low vision, hearing impairments, or like limited motor skill or color blindness. And say with me, that's actually wrong, because Accessibility Act, mobile apps and accessibility features makes our app easy to use, intuitive, and understandable in difficult environments. So anyone can enjoy by accessibility features. I mean, you wake up today with some foggy weather outside, so I try to ask yourself to be a bit to use a bit of imagination, because I want to explain what is a difficult environment. So imagine, even if it's winter, that you are at the beach, maybe wearing your sunglasses and trying to use your phone. A good color contrast, so low vision features can actually help you to use your phone. Mobile apps are central on how we communicate, work, and navigate the world. So making an accessible app is not just an option, it's a necessity. So now we have seen why accessibility matters and how to achieve it. So we move on in the second part of the agenda, where I would like to explore the fundamentals of accessibility in Jetpack Compose. We will actually know how the frameworks works under the hood. So when we think about Compose, a composition describes the UI of your app and is produced by running composable. And the composition is represented as a tree structure. So we have each node that have all the information that helps the framework to know how to draw a composable. So all the visual information, like for example the background color, the padding that we have on the column of the screen, like the painter of the images, or the alignment or the text size and text style. But if you paid attention to the talk before, you know that not everyone interacts with the app in the same way, because we cannot rely only on visual information, because people actually can use like external devices like keyboard or assistive technologies. In the Android world, the most common assistive technologies are the TalkBack, which is the screen reader that provide spoken feedback for visually impaired users. And also we have the voice access, which is an hands-free control, so you can use your phone by voice commands. So how this assistive technology can actually understand what's on the screen? They can understand it because alongside the Compose UI tree, we have a semantic tree that is actually a parallel tree that have different information. So inside it does not contain information on how to draw a composable, but it has information about that describe in a semantic way what's the meaning of that composable. So we arrive here, and you might ask yourself why we don't have just one tree with both the information, the visual information, and the semantics information. And actually, we don't have it. We have two separate trees, because usually the semantic tree is a simpler way, is a simpler perspective of a tree structure, because it actually omits elements that have no meaning for accessibility. Like, for example, you can see here that we turn the image that before has a content description to a decorative image. This is like a background, for example. And doing so, this node is actually omitted by the tree. So to deep dive inside what there is actually inside this, which is the information that is inside these nodes. These nodes are called accessibility node info. And with this information that are representation in a semantic way of what's displayed on the screen, all of these information are used by assistive technologies like TalkBack and voice access or accessibility services. And actually with this information they can navigate, go through nodes and make announcements. Typical properties of these nodes are the role, where we describe which is the actual role of an element. Actions, where we represent a set of the interaction available with the node. And then we have labels that, for example, is pretty useful for images, but also for text. So the assistive technologies can get this label and announce it to the user. So most of the time, we do not have to care about this, because if we use material and foundation components, they actually support accessibility out of the box. Okay? I hope it has not finished, because I promise you to go first to the food, but okay. Sorry about that. So most of the time we do not care about the properties because they're actually pre-filled by the material and foundation components. So for example, if you use a material button, it has already action, labels, and roles specified. So just before we move on to the third part of the agenda, I would like you to raise your hand if you have ever watched or you're a fan of The Office US edition. the TV series? Few? Okay, Breaking Bad or Community? Nice, thank you. I just need it for myself, not for the presentation, no worries about that. There are cases when sometimes, because maybe the designer designed a different element, where we want to create custom level composable, or we want to change the default behavior of a composable, just to enhance the experience to the user. So in this case, our best friend is the semantic modifier. With the semantic modifier, we can actually set the semantic properties that are used by assistive technologies and that describe the element. So like in this case, for images, we can set the content description of the image, and we can use the property of the modifier semantics or the direct property of the image. Then another example is roles. For visually impaired user, might not be obvious to, there's no obvious way to tell if an element is a multiple selection element or a single selection element. So to do so, we use the role. And with the role, we can specify actually the role of the element. So if it's a checkbox, for example, is a multiple selection element. If it's a radio button, it's just a single selection. Then, as a third example of a property that we can set with the modifier semantics, we have the state description. By default, the state description is on or off. So so the talkback and the assistive technologies just announce as an on or off the state of an element. But in some case, just to enhance and give more context to the user, we might want to change the behavior. And to do so, we can do it by the state description to set if it's an Heisenberg mode or is a Walter White mode. And other cases where we can use the modifier semantics to enhance the information that we provide to the user is when we want to improve navigation in complex scenario. And you should know that the swipe right gesture, it's actually the most famous gesture of a dating app, but also of the talkback. So moving and doing a swipe right on the screen, we can actually move through nodes and go by each. The default ordering is from the top to the bottom and left to right. So if you do the first swipe right in this example, we actually put the focus on the image of Michael Scott. Then if we swipe right again, okay, we go to Michael Scott, then regional manager, and then in the end we reach the Dunder Mifflin. But sometimes it might be better to group a set of elements and actually use it like a single node, like as a single node. And to do so, we can use the merge descendant properties. So by setting the merge descendant properties, we are actually saying to the talkback to get this element and actually use it like a single node. So if you do the first swipe right, oops, sorry. Okay, if you do the swipe right, we just put the focus on all the elements. And the assistive technology is going to read all the nodes inside, but just treat them as a one single node. There are cases when we, like in this example, we might want to put a button inside a merge descendant node, and a button just itself inside, it declares itself as a merge descendant node. So how does it work when it is like this? On the documentation, Android said that the default policy is not aggressive. So actually the two nodes remain separate. So if we do a first swipe right, we put the focus on the entire element. Then if we do another swipe right, we goes inside and we put focus on the merge descendant node inside the parent node. Pay attention, because with some modifiers like clickable, for example, or toggable, they actually just inside them set the property as merge descendant. So just pay attention when you use them. We now move on to another example where we actually just move the Dunder Mifflin to the right of the name of Michael Scott. And doing so, we are not anymore in the merge descendant example. And doing so, if we do a swipe right, we just put focus on the image, then again to Michael Scott, then we move right to Dunder Mifflin, and then we go straight to Regional Manager. But you know, for a user, maybe a user just want to hear Michael Scott, Regional Manager, Dunder Mifflin. They don't want to hear like Michael Scott, Dunder Mifflin, Regional Manager, because it might be confusing. So how we can achieve this behavior? We can achieve it by setting the entire group, the parent group, as a traversal group. So the traversal group property. And then we can set for each element inside a traversal index. So the ordering is from the lowest value to the highest value. So it goes, in this example, it goes from Michael Scott, then, sorry, the image of Michael Scott, the world's best boss, then Michael Scott, then it goes to Regional Manager, and then at the end to Dunder Mifflin. There's also another way to do that, because the default value for the traversal index is actually 0. So to achieve this behavior, you can just set 1 to the node of Dunder Mifflin, and you can get the same behavior. But in my humble opinion, this is the clearest way to reach the same result. But sometimes not all is working as expected. I don't know if this one is a bug or a feature made by Google. So if there's any Googler in the audience, maybe they can tell me. But actually, if we set merge descendant to the parent node, this will clear your traversal ordering, okay? So in the previous example, if we set merge descendant, it will announce before the image, then Michael Scott, then Dunder Mifflin, just at the end Regional Manager. So how we can overcome this kind of bugs? We can overcome with ClearAndSetSemantics. Because with ClearAndSetSemantics, when we set ClearAndSetSemantics, all the descendant nodes will be cleared, the semantics of the descendant nodes, and we set a new one. So to overcome, to overcome the bug that we have seen before, bug or feature, whatever, we just have to set to the parent element ClearAndSetSemantics, and then set a custom content description to the element. If we want the talkback to do a quick pause, we can set like the \n. So actually the talkback, when it's reading a complex content description, is going to make a pause. But as is written on the documentation, use it carefully, ClearAndSetSemantics, and do not abuse it, because it's actually a powerful tool. And now we see a last example of an extra modifier that we can use to actually improve navigation. I don't know if the quality of the GIF is nice, but actually with the talkback, a user can actually cycle through reading options and choose the one that best suits his needs. For example, like this, he can set the heading as a reading option, and with a single swipe right, it goes through just heading elements inside the screen. How we can identify an element as a structural heading? We can identify it by setting the header property in the semantics modifier. So we just change a little bit. Now you will hear the video in your, you will see a video and hear the sound in your headphones. And I want to talk about the status changes. So we cannot rely only on visual information when we want to do a status change, because visually impaired user won't get this information. So what is a status change? It is actually when we want to provide a feedback to the user without asking to the user to move the focus to the element. Okay? And to do so, we can use the LiveRegion. So now I'm going to play the video. So you can just give me a thumbs up when it's finished, okay?
What is the name of the show hosted by Troy and Abed? Mornings with Troy and Abed. Button. Double tap to activate. Troy and Abed in the morning. Button. Double tap to activate. Correct. Troy and Abed in the Morning is a talk show that Troy and Abed host, usually inside group study room if it is done in the style of the morning talk show format.
I believe the video is done, okay? So I can assure you that I haven't done any gesture. My last gesture was just to select the correct answer. And once I select the correct answer, we change the visual information of the parent container, and with LiveRegion mode on, actually the talkback has provided you the status change. We can set two different modes. One is polite and one is assertive. The difference between these two is that with the polite mode, I mean, it's polite. So if the talkback was reading something, it just announce the status change just after it is ended to read something. With assertive mode, it just stop and make the announcement of the status change. So we reach the third part of our agenda, which is testing, which is one of my favorite topic. And as developer, I can see someone that is laughing. It's clearly a lie, but okay, just move on. How we can test for accessibility? We can test with analysis tools. We have some analysis tools, which are Compose UI Check and Accessibility Scanner. The Compose UI Check is inside Android Studio, and it just runs our preview in different in portrait or landscape mode with different font size and colors, and just like warn us if they can find some like improvement in accessibility. So like in this example is setting me that there's an insufficient color between the background and the text color. I don't know if the guys of Android Studio are still in the audience, but it's not so intuitive to enable it, because you have to open the preview, move your cursor on the name of the preview, wait a few seconds, then it appears a button. You can select the button and then you have your Compose UI Check running. Another way is by using the Accessibility Scanner app, which you can actually download from the Play Store. And with the Accessibility Scanner app, we can capture a screenshot of our app or record like a session. And then at the end, the Accessibility Scanner app will give us some tips on how to improve the accessibility. And it's actually told me the same thing that the Compose UI Check was saying before. Then we can test with automated testing. Actually, automatic testing, we have like the UI testing for the test case. This is not the main purpose of the test to check for accessibility, because these finders, matchers, and assertion are used for pretty much normal UI test. But we can leverage on some features, like on Node with content description, for example, to actually check if we provide a correct content description to the element, or state description, for example. Or we can do custom matchers and check the property that we want to check. And then, last but not least, this is probably the most important of all of them. It is testing your app with accessibility service on, because actually this helps to check the overall experience of the user and highlights some areas of improvements. We reached the end. I'm still answering some questions. Good. By designing mobile apps that everyone can navigate and enjoy, we're not just building better products. We are creating a more inclusive digital world for millions of people. So let's ensure that no one is left behind. Accessibility is not just a feature, it is a necessity, as your lunch is. So thank you guys, and enjoy your meal.
Thank you so much.
Thank you.